Hello everyone, this is another video on atomic and molecular physics. Okay. So here we'll be discussing about Zeeman effect, right? Zeeman effect. So what is Zeeman effect? First of all, Zeeman effect is effect of effect of magnetic field, effect of magnetic field on fine structure lines, on on fine structure lines. Okay, this is called a Zeeman effect. So what is it exactly? Okay, there are two types of Zeeman effect: normal Zeeman effect. There are two types of Zeeman effect: normal Zeeman effect and this is on 9 anomalous Zeeman effect. Anomalous Zeeman effect. Okay, normal Zeeman effect and anomalous Zeeman effect. Right? Okay. Okay. So we'll study them one by one. What is a normal Zeeman effect? First of all, normal Zeeman effect. Okay, normal Zeeman effect. What is normal Zeeman effect? Where here spin S is equal to 0. Okay, that means it's a singlet state. The transition is between singlet to singlet transition. Singlet to singlet transition. Okay, singlet to singlet transition. Right. So we know J is equal to what? L plus S. So here S is 0, so L. So here J is equal to what? L. Right. And this works for here. Okay. Line here line splits into how many components? Line splits into two or three components. Okay. Two or three components. Alright. And okay, what is the selection rule for it? Selection rule for normal Zeeman effect. Selection rule for normal Zeeman effect. Okay, what is the selection rule? Del m is equal to del m l is equal to 0 plus or minus 1. Why del m l? Because j is equal to l, isn't it? Okay, del m is equal to 0 plus or minus 1. Okay, now if your del m l is equal to 0, that is linearly polarized. Okay, then this is your del ml is equal to plus 1, that is and del ml is equal to minus 1, so sigma. Okay, circularly polarized. Okay, circularly polarized. So from it we can conclude that the what light emitted along or parallel to B is actually what? It's circularly polarized. Okay, when light emitted perpendicular to B is what? Linearly polarized. Okay. So, what is the separation between consecutive lines? Separation separation between consecutive lines. Okay, what is the separation? Del V is equal to GL EB by 4 pi m into, okay, yeah, GL EB by 4 pi m. Then del lambda will be written as del lambda is equal to lambda square by C GL EB by 4 pi m. That means lambda square by C into del mu, isn't it? Okay, this is del mu, sorry. Del mu. How? Because Hc lambda is your energy, right? That is H so minus C by lambda square del lambda is equal to del nu. So del lambda is equal to, if we take the magnitude, lambda square by C del nu. Okay. So del lambda is equal to lambda square by C GL EB by 4 pi m. Okay. 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 Let's write a question and solve it. Atomic part, I think question number. If you remember, I don't remember the question number. 20, 27, 28 or something. I don't remember. Okay. The spectral line, the spectral line corresponding to an atomic transition from, you write the question along with me. J is equal to, sorry, J is equal to 1 to J is equal to 0 states splits into a magnetic field of 1 kilogauss. This is not kg, kilogram. This is kilogauss. Okay. Into three components, okay, separated by 1.6 into 10 to the power minus 3 angstrom. If the zero field if the zero field spectral line if the zero field spectral line corresponds to corresponds to 1849 angstrom, what is the uh, g factor it is the g factor corresponding to the j is equal to 1 state. We will read the question three times. Okay, three times read the question. Just read the question, no need to solve it. First read the question three times. The spectral line corresponds to an atomic transition between j is equal to 1 to j is equal to 0 state, splits into magnetic field of 1 kilogauss into three components separated by 1.6 into 10 to the minus 3 angstrom. If the zero field spectral line corresponds to a 1849 angstrom, what is the G factor? So Landé G factor is asked. Corresponds to J is equal to 1 state. So spectral line corresponds to an atomic transition from J is equal to 0 to J. So J is equal to 1 to J is equal to 0. Okay. Magnetic field of 1 kilo. So magnetic field is given. Magnetic field is given how much? 1 kilogauss. That means 10 to the power 3 Gauss. That is 10 to the power 3 into 10 to the power minus 4 Tesla. 1 Gauss is 10 to the minus 4 Tesla. 10 to the minus 1 Tesla. Okay. Separated by 3 into 3 components separated by 1.6 10 to the minus 3 angstrom. If the zero field spectral line corresponds to 1849 angstrom, okay, zero field spectral line corresponds to 1849 angstrom. Just put it. Lambda is given, right? 1.6 10 to the minus 3 angstrom. That means 1.6 into 10 to the minus 13 meter. Okay. Mm, Zero field spectral line corresponds to this. Sorry. This is not. No. This is lambda. 1849 angstrom. This is your lambda. Okay. Minus 10. This is your lambda. So, and this three components separated by 1.6 10 to minus, that is your del lambda. So del lambda is a separation of lines, isn't it? Del lambda you can see. That means change. That means separation. Minus 3 angstrom, then minus 13 meter. So, what is the Landesi factor? Simple. What is the formula for it? What is the formula for Landesi factor? Tell me first. G is equal to GL is equal to what? What is the formula? First of all, what is the formula of del lambda? Tell me. Del lambda is equal to lambda square by c into G mu b b by h. Cut. Okay. This is the formula for del lambda. You can ask me how. How did it come? It's very simple. So G will be, but everything take to the other side. This is only h. Okay. So h del lambda by lambda square c into 1 by mu b v. Alright? Yes? Yes. Now what? Now see. mm, there's another thing if you can remember from here. Uh, just a second. If c by mu b has a value, so what do you do? Multiply c in the numerator and denominator. So it will give me like this. If c by mu b has value 2 into 10 to the power 2 meter. Okay, and del lambda we know separation 1.6 10 to the minus 13 by lambda. Lambda is your 1.8 into 10 to the power minus 10 square into c square 9 into 10 to the power 16 into b Tesla. The Tesla one, what is it? 10 to the minus 1. So if you put everything, all the values, you will get the answer g is equal to almost 1. Okay, this will be what you will be getting. So this is a Landesi factor. Okay, formula based question, nothing much, right? Del lambda is equal to lambda square by c. Again, I will write the formula del lambda to lambda square by c g mu b b by h. G mu b b by h. Okay, how do you get it? Energy we know. Energy how much? E is equal to G. Okay. C by lambda. Take the derivative. We got h by lambda square into del lambda, isn't it? So you take everything to this side. So we del lambda. Okay. Another thing, yeah. Next question. What to write next question? Next question is almost the same. Okay, it's the same question. So anyway, I will just write the question. You have to solve it. Let me go to PPT. This thing is not working properly here. Okay. So now I'll add the next question for you. Question number 2 or 3, whatever it was. 29. So 29. Question number 29. 28, which was the previous one. Item, an atomic transition. What is this? Yeah. An atomic transition. Okay. 1p, 1s, 1s in a magnetic field. One Tesla. Source Zeeman effect. Source Zeeman splitting. Okay. Source Zeeman splitting. Given that, given that the Bohr magneton mu b is equal to 9.27 into 10 minus 27 joule per Tesla. Okay, and the wavelength corresponding to the transition corresponding to the transition is 250 nanometer. The separation in Zeeman spectral line is approximately is approximately how much? Atomic transition 1p to 1s in a magnetic field of 1 Tesla. Okay, so Zeeman splitting. Given that Bohr magneton mu b is equal to this much, wavelength corresponding to the transition is this much. The separation in Zeeman spectral line. The separation in Zeeman spectral line. So what is our separation? That means what? Del lambda, isn't it? Del lambda is being asked. Wavelength is given 250 nanometer, 250 10 to the minus 9 meter. Alright, mu b is given, Bohr magnet of 9.27 10 to the minus 27 joule per Tesla. Okay, so what do we have to find here? We have to find del lambda. What is the formula for del lambda? Del lambda we know. Del lambda, and del lambda we know. Lambda square by c gl eb by 4 pi m. Okay, eb by 4 pi m. So del lambda is equal to lambda square by c gl mu b. Okay, this is your mu b, isn't it? This is your mu b. Okay, so next is what? Hmm, otherwise, wait. What we have to do is del lambda is equal to lambda square by c. Hmm, we will multiply h, divide h. Okay, h, h. Yeah, now it's right. Yeah, now it's right. EH by 4 pi m. This will be what? Mu b. So let's go by c mu b b by h. Okay. So lambda is given. This is the original formula we studied did in the previous question also, isn't it? So lambda is given. Lambda is given how much? 250 nanometer. 250 nanometers 9. 300 over 8. GL is how much? GL is GL is 325 8. Then GL is 1 and GL is 1. Sorry, this pen is. I don't know what is happening with this pen today. One into the value of mu. We just put the value of mu v and 1 Tesla. Okay, that will be the answer. Okay, same thing, just formula based question. Right? Okay, next question.
सारे एग्री कर रहे हो इस चीज से? आप सारे लोग इस चीज से कंप्लीटली एग्री कर रहे हो? यस और नो? हाँ या ना, जरा गौर से देखो प्लीज। सारे लोग का ठीक है?
Okay, next. These questions are very easy. Next will be anomalous Zeeman effect. Okay. Next will be your anomalous anomalous Zeeman effect. Here S is not equal to 0. Okay, this is a multiplied state. Okay, multiplied state. B is weak here. Okay, line splits into 4 or more components. 4 or more components. Okay, and what is the selection rule for it? Selection rule here is del mj is equal to 0 plus or minus 1. Okay, 0 plus or minus 1. What is the case in case of normal Zeeman effect? Normal Zeeman effect also same. Okay, but that was, yeah, that was line was splitting into two or three components. Okay, okay. So here now, um, what what is the state of polarization? What are the states of polarization in this case? So when viewed perpendicular to B, that is a what? Plane polarized. Okay, perpendicular to B, plane polarized. Here Mj del Mj is equal to plus or minus 1. Okay, plane polarized, perpendicular to B. This one is what? For example, del Mj is equal to 0. That is also plane polarized. This is parallel to B. Okay, these ones we have to remember. Okay. Now when viewed when viewed parallel to B, del mj is equal to plus or minus 1, that is circularly polarized. Okay, circularly polarized, and del mj is equal to 0, that is forbidden. Alright, what is the energy shift in this? Energy shift formula is del nu gj dB by 4 pi m. Okay, and del lambda is also here, same, del lambda square by c gj dV by 4 pi m. You have to remember this formula. Okay? Was I muted? Please let me know in the comments if all these were just muted. See if it was muted. See states of polarization. If perpendicular to B, it will be plane polarized. So del mj is equal to plus or minus 1. So it is plane polarized perpendicular to B. If del mj is equal to 0, it is plane polarized parallel to B. Okay? And these are the conditions. Del mj is equal to plus or minus 1, it is circularly polarized when waved parallel to B. Del mj is equal to 0 and it's forbidden. Okay? And this is the same formulas here. Okay. The next question. This is important here. This question. Write down. Question number. How much it will be? 30, I think. Right. Okay, write down. An atomic spectral line is not working. This color is not good. So an atomic spectral line is observed to split into nine components. Split into nine components due to Zeeman shift. Due to Zeeman shift. Okay. If the upper state of the atom, if the upper state of the atom is 3d2, then the lower state is. Then the lower state will be an atomic spectral line. Okay, options are 3f2, 3f1. These type of questions will come. Okay, 3p1, 3p2. Tell me, an atomic spectral line is observed to split into 9 components due to Zeeman shift. If the upper state of the atom is 3d2, then the lower state will be. Okay, first try. You first try this question. Then only I will solve it. But you first try it. Take your time. I'm giving you 2 minutes to think. Think about the selection rule here. What is the selection rule? Zeeman shift. What is the S value here? What is the S value? See, S is equal to 0 is your normal Zeeman effect, and S not equal to 0 is your anomalous Zeeman effect. So, see, here S is how much? 3d2. What is S? What is S here? What is S here? See, read the question. You have written the question. A atomic spectral line is observed to split into 9 components. Okay, to have split whatever. Due to Zeeman shift, the upper state of the atom is 3d2, then the lower state will be. Okay, so upper state of the atom is 3d2. Okay, 3d2. What is the spectroscopy notation? 2s plus 1 Lj, right? So here 2s plus 1 is equal to how much? 3. 2s is equal to 2. S is equal to what? 1, isn't it? So S is equal to 1. We know S is equal to 0 is a normal Zeeman effect. S not equal to 0, that is anomalous Zeeman effect. So this is part of what? Anomalous Zeeman effect. That is the first thing. What is the selection rule in anomalous Zeeman effect? Del ml is equal to 0 plus or minus 1. Okay. Del ml is equal to 0 plus or minus 1. Alright. So let me draw 3d2. So 3d2 means splitting, like this is 2, j is equal to 2. So del m, the mj's will be what? Mj values minus 2, minus 1, 0, 1, 2. Okay. Okay. So 3d2. 5 states, right? Plus 2, plus 1, 0, minus 1, minus 2. These are the mj values. So del mj is what? 0 plus or minus 1. Alright. So 0 plus or 1 minus 1 means How can we do it? See, these are what are the values here? Plus 2, 1, 0, minus 1, minus 2. How will you do it? 0 plus or minus 1 is the. So let's check what is the 0 change. 0 change 0. Minus 1 is minus 1. Plus 1 is plus 1. For this one, 0 is minus 1. Minus 1 is minus 2. Plus 1 is 0. This one, minus 3, minus 2, minus 1. Right? Okay. This is your what? 0, 1, minus 1. Sorry, 0, 1, 2. This is what? 1, 2, 3. Okay. So, so how will we do it? How to do this? Hmm? Can you tell me? Okay. We will do what? Let's do with options. If you are not able to solve this way, we will do through what? We will do through options. Okay, let's see. So this is your 3D2. Is 2 plus 1, 0, minus 1, minus 1. I hope you have written the question in which the first option was 3F2. What happens in 3F2? This is your uh, again 2, 1, 0, minus 1, minus 2. Okay. And here is also 1. So check how many lines can you draw. Okay, 9 components. Huh? Is observed to do 9 components. So check whether 9 components are being can be observed here or not. Minus 2 to minus 1, minus 2 is 1. Minus 2 to minus 1, minus 1 to minus 1, minus 1 to 0. No, minus 1 is not allowed. 0 to 0, 0 to minus 1, and 0 to 1. Okay, 1 to 1, 1 to 0, 1 to no, not possible. 1 to minus 1, not possible. Okay, 2 to 2, 2 to 1. Okay, how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 lines possible here. But we need what? 9. So this is not answer. Simple rule, del mj is equal to 0 plus or minus 1. So these are the mj values. So I just checked the splitting. Okay. Alright. This way we can check the second option. Second option is what? 3f1. Check yourself this one. 3f1. See 3f1, how many values? This is j, minus 1, 0, 1. Now check. Minus 2 to minus 1 are only possible. Minus 1 to minus 1 possible. Minus 1 to 0 to possible. 0 to 1 possible. 0 to 0 possible. 0 to minus 1 is possible. 1 to 1 possible. 1 to 0 possible. 2 to 1 possible. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines. We're getting 9 lines here. Okay. But is it correct? Is it correct? We're getting 9 shades here. See, there is a thing here. It's a very good question. 3F1. See very carefully. 3f1. Okay, 2s plus 1 is 3. S is how much? S is 1. 1 mean, okay. F means what? S, P, D, F. What are the L values? 0, 1, 2, 3. So F, for F, L value is 3. So L is 3. S is 1, L is 3. So what should be the J values? L plus S to L minus S. That means 3 plus 1 to 3 minus 1. That is what? 4, 3, 2. So J value should be what? 4, 3, 2. What is the J value in 3 of 1? 1. So this state is first of all not valid. This state is first of all not valid itself. Okay. This step is not even valid. So how can we what say that there are 9 splittings? Okay. So first we have to check the state. Right. So this is not correct. This is not correct. Next, check the option 3. Option C 3p1. First tell me whether this is a valid state or not. First tell me whether this is a valid state or not. I just did it. 2s plus 1 is equal to 3. 3. So s is equal to 1. P. S, P, D, F. L value 0, 1, 2, 3. So for P, L value is 1. So J values can be L plus S to L minus S. So 1 plus 1 to 1 minus 1. That means 2, 0, 2, 1, 0. So yeah, 1 can be the value of J. So this is a valid state. Okay, let's check the splitting then. 3D2, right? And our 3P1. 3P1 means J value is 1. That means splitting will be 1, 0, minus 1. Okay. So here again 3, 4, 5. Sorry for this very paint line. 3P1 is 1, 0, minus 1, minus 1, 0, 1. This is 2, sorry, 2, 1, 0, minus 1, minus 2. What is the selection rule? Selection rule is del mj is equal to plus or minus 0 plus or minus 1. Anomalous Zeeman effect. Okay. So check now. Check now. Minus 2 to minus 1 possible. Any other is not possible. Minus 1 to minus 1 possible. Minus 1 to 0 possible. 0 to 0 possible. 0 to 1 possible. 0 to minus 1 will be possible. 1 to 1 possible. 1 to 0 possible. Yeah, 1 to minus 1 not possible. 2 to 1 possible. Yeah. So how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 lines. Clear? Is it clear? Is it clear? 9 lines possible. So this is your answer finally. Okay. 3P1. In CSR net, this will come for 5 marks. So it's worth it if you give it 10 minutes. Because giving 10 minutes will give you 5 marks. At the end of the day, you will get 5 marks. So don't think about time, that much time, because time you will get enough time. Okay. Because you won't be able to solve so many questions that the ones you are able to solve, don't miss it. Okay. Even if it takes 10 minutes, don't let it go. Alright. In gate it will come for 2 marks. Don't let it go. Okay, these 2 marks will have ranks like 300, 300 and 300 people will be inside these 2 marks. So yeah, don't leave this. Okay, so this question is solved. Okay, very good question. Our your concept will be really clear through this. Okay, so this was what Zeeman effect. All right. Next is the write down Paschen-Back effect. Next write down Paschen-Back effect. I like this color. Paschen-Back effect. PBE. Okay, here what? S not equal to 0 and your magnetic field is strong. Okay, magnetic field is strong. So number of lines is equal to 2 or 3. Okay. So omega L is equal to GL EB by 2m. Okay, and here EB by 2m because G is 1. Omega S is equal to GS EB by 2m and GS is equal to 2 EB by GL is equal to 1 and GS is equal to 2. Okay, what is the energy splitting? Your energy shift, sorry, energy shift will be E is del E is equal to ml plus 2ms, okay, mu bb, ml plus 2ms mu bb. Just please remember this formula. ml plus 2ms mu b into b. This is your del E energy shift. Please remember this formula, please. This will come in your exam. Okay. Selection rule in passion back effect. Selection rule. Remember this del ml here is 0 plus or minus 1. Can you tell me why I am getting both del ml del ms? Because s is not equal to 0. Huh? That's why. In normal Zeeman effect, s is equal to 0. That's why I was only getting del ml. But here, s is not equal to 0. That's why we are getting both del ml and del ms. Okay. So 0 plus or minus 1. Del ms is 0. Del ml is 0 and plus or minus 1. Del ms is 0. Okay. Maximum maximum partition back effect level, maximum PB level, partition back. PB level, what is the formula for it? 2s plus 1 whole into 12 plus 1. Okay. 2s plus 1 whole into 12 plus 1. Okay. Okay. So for example, we will do an example. Example is splitting of sodium splitting of sodium D line in the presence of strong magnetic field in the presence of strong magnetic field. How sodium D line splits in presence of strong magnetic field? We'll see that here. Okay, I will do it in another slide. See, so sodium D line. Okay, so this is what 3p to 3s. The sodium D line splitting is 3p to 3s. All right. So 3p. Tell me the values. L is equal to 1. Okay, S is equal to half. S is equal to half for electron. So what are the ml values? ml values are 1, 0, minus 1. What are the S values? Half, minus half. Okay, mass half. Sorry, half minus half. So 3s, L is equal to 0 and S is equal to half again electron. For electron S is equal to half. So ml values is 0. Ms value is what? Half minus half. Okay, half minus half. Now then, now we will draw that table. ml, ms, ml plus 2ms. Here also ml, ms, ml plus 2ms. So ml is 1, 0, minus 1. ms is, as we know, half. So this will be your 2 if you put the values. 1 plus 1, 2. 0 plus, this is 1. Minus 1 plus 1, 0. Okay. On this side, 1, 0, minus 1, minus half, 0, minus 1, minus 2 if you put the values. Okay. Another one is, okay, another one is, another table will be ml, ms, ml plus 2ms, here 0, 0, half, minus half, that will be 1 minus 1. Okay. This is for what? This is for the second case. I'm really sorry. This one is for this. Okay, I'm really sorry. I did it this way. This one is here. Okay, yeah. So we will do the splitting now. Okay, let's do the splitting. The fun part. 3p, 3s, 3p. Okay, 3p. We just did 3p will be splitted into what? It will be c 2 1 0 minus 1 minus 2. 2 1 0 minus 1 minus 2. 3s will be 1 minus 1. 1 minus 1. Alright? 1 minus 1. Okay? How I did it? You must be thinking how you did it. You just wrote it. See, we did it here. 3p. This is 3p, right? 3p. See what are the values? ml plus 2ms, right? ml plus 2ms I have written. Splitting is, where is it? Yeah, see, this is the splitting ml plus 2ms, isn't it? So see, for 3p ml plus 2ms values are 2, 1, 0, 0, minus 1, minus 2. Okay, I will do one. I will tell you another thing here. 2, 1, 0, 0, minus 1, minus 2. So how many splittings? 1, 2, 3, 4, 5, 6. Is it 6? No. It's 5. It's 5 lines. Okay, 5 lines splitting, 5 components. 5 components is just that one component has degeneracy 2. Degeneracy, okay? This is degeneracy 2. Because 0, 0, 2 values, so degeneracy is 2. But actually this is 5 components. Okay, so this is for 3p. For 3s, this is for 3s. For 3s, well, values are 1 minus 1. So I did 1 minus 1. For 3p, 2 1 0 is minus 1. I'm sorry, minus 1 minus 2. Okay. So here, how will we do the splitting? What is the splitting rule here? Splitting rule is del ml 0 plus or minus 1, del ms 0. Okay, del ms is 0. So now you do the splitting. Try. Try. Okay. So 0 plus or minus 1, that is the basic thing. So minus 2 to minus 1 possible. Minus 2 to 1 is not possible. It will give you minus 3. Minus 1 to minus 1 possible. Okay. Minus 1 to 1 not possible. It will give you minus 2. 0 to 1 possible. 0 to minus 1 possible. Okay. 1 to 1 possible. 2 to 1 possible. Okay. Alright. Isn't it? Isn't it? Hmm? I can write it as 0 0. Okay. Did I miss anything? Just check and tell me. Did I miss anything? Yeah, 0 to 1. Yeah, it's there. So how many lines I'm getting? One, 2, 3, 4, 5, 6. Let's arrange it a bit. Okay. 6 lines. I'm getting 6 lines. Alright. So this is it. Hmm. This is 6 lines for sodium D line. Okay. 3p to 3s. Sodium D line. How many lines? 6 lines. Okay. So this is you can draw it here. This is called D line. No, it's not line. Line. It's D line. Okay. Question like is on. One more thing is left. That's it. That will be the video. That is Stark effect. Stark effect. What is Stark effect? Splitting of atomic energy. I hope after this you can do questions on your own after watching this lecture. Splitting of atomic energy. Okay, energy levels in the presence of external electric field. The presence of external electric field is called your Stark effect. Okay. So what is linear Stark effect? Linear Stark effect. Linear Stark effect. What is it? That means it is a weak field effect. The weak field is weak. Selection rule is what? Selection rule. Selection rule is del mj is equal to 0 plus or minus 1. Okay. What is the energy shift? Energy shift. Energy shift del E is proportional to actually electric field. It depends on what external electric field is applied. So this is your del E. Okay. No linear Stark effect. No linear Stark effect in ground state. There is no linear Stark effect in the ground state of hydrogen atom. Okay, remember this. This will come as a MSQ question. Okay. Yeah. Next is for first excited state of hydrogen atom. Okay, leave it. Next is this was linear. Next is quadratic Stark effect. Quadratic linear, then quadratic Stark effect. Sorry, this is Mitchell's, not this is Mitchell's Stark color Stark. The quadratic Stark effect, that is the strong field effect. Okay. Selection rule is what? Selection rule. Selection rule will be del ml is equal to 0 plus or minus 1. Del ms is equal to 0. Okay. Yeah. See, there is nothing, everything there is 0 plus or minus 1. So just, yeah. Okay. Okay, there is just remember a formula. Just remember a formula. In ground state of hydrogen atom, in ground state of hydrogen atom, okay, del E ground, that is really ground, is equal to minus half alpha E square. Where alpha is a what? Alpha is a polarization. Okay. So this was your what? Stark effect. Right? So what we studied in this class? We studied Zeeman effect, Stark effect. We did some splitting and all. We did some numericals. Okay. I hope you understood this splitting things. We'll do more splitting. Okay. I also really like doing splitting things, like splitting and all. So we will do more and more splitting in upcoming videos. Okay. So stay tuned. Thank you for watching. Thank you very much.